Hello, and welcome to the NARUC Center for Partnerships and Innovation, Regulators Financial Toolbox on Cloud Computing. Next slide, please. This program is sponsored with support from the U.S. Department of Energy and NARUC Center for Partnership and Innovation. You can find more information about us on the website, but we are a grant-funded team that identifies emerging challenges and connects state commissions with expertise and strategies. Next slide, please. On today's webinar, we have the moderator, Commissioner Diane Berman from the New York Department of Public Service. The webinar will be recorded. At any time, please chat us to ask any questions about the logistics or any question for the panelists. We will engage in a dialogue and Q&A at the end of each panelist's 15-minute presentation. Next slide, please. Now I will turn it over to Commissioner Berman, Commissioner at the New York Department of Public Service. Commissioner?
Thank you so much. I appreciate being here. I'm really looking forward to moderating this webinar, which is one of the webinar series for the Regulators Financial Toolbox series, where we are going to get under the hood on cloud computing. Services such as data storage or software were traditionally accessed by purchasing an application that would be stored on a computer's hard drive. However, in recent years, many of these services have been offered over the cloud. Now, cloud computing in its simplest form refers to accessing these services over the internet instead of your computer's hard drive. Leasing arrangements that allow lessees to access these services from a provider over the internet are also referred to as a software as a service contract. These services accessed via the cloud can be more easily updated, which allows for technological changes that help promote innovation. There have been discussions over the years on whether the current accounting for these software as a services contracts is appropriate in a regulated environment and what we may need to do. Purchase applications are accounted for in the same manner as other capital assets. The utility pays for the application up front. The cost is utilized on the utility's books and amortized or expensed over the life of the asset, and the utility earns a return on the unamortized balance. Now, these software as a service contracts are typically considered operating leases, and therefore the majority of the costs, including the periodic lease payments, are expensed as incurred. This is under generally accepted accounting principles, or GAAP. If a lease is prepaid, the unamortized portion of the prepayment can be included in rate base and earn a return. This scenario was specifically discussed in New York's order adopting a rate-making and utility revenue model framework back in May of 2016. There has been discussion that these accounting rules results in an incentive for utilities to purchase applications in order to earn a return on the unamortized asset balance. And there's been consideration in recent years about how to level the playing field to help utilities and ultimately their customers making the best decisions for operations. Now, regulatory attention to the cloud was first formally recognized by NARUC as a whole back in the 2016 annual meeting of the NARUC's annual meeting. At that time, NARUC adopted a resolution encouraging state regulators to improve regulatory treatment of cloud computing arrangements. While that's been a while and while we've moved also beyond that, it is important to take a step back and look at what the resolution said. The resolution language talked about that utilities should be free to make software investments based on which option best meets both the needs of the utility and its customers, rather than how the investment will be treated for accounting purposes. It went on to say that regardless of how cloud computing is treated for regulatory accounting purposes, regulators will still examine whether the investment is prudent. And it resolved that NARUC was encouraging state regulators to consider whether cloud computing and on-premises solutions should receive similar regulatory accounting treatment, in that both would be eligible to earn a rate of return and would be paid for out of a utility's capital budget. For me, the resolution was very important because it did show formally that regulators were looking at these issues, what the value the cloud could have to the utility industry, ways to explore barriers that may be there, perceived or otherwise, of not being able to capitalize investments, and really about getting beyond just the financial treatment of it, which is very important, but really helping to enable utilities to make strategic decisions that were best for the operations and ultimately then perhaps best for the customers. For us, we also need to look at not just the NARUC resolution, but what is being done at in the Financial Accounting Standards Board, or FASBA. In 2018, FASBA issued a regulation guideline which states that certain implementation costs for cloud computing arrangements can be capitalized rather than expensed. This was an update to the accounting rules that helped align the accounting for costs incurred to implement cloud computing arrangement with those associated with implementing internal use software. Most costs incurred under SaaS contracts are still required to be expensed. FERC and NERC have also weighed in. In December 2019, FERC issued a guidance document affirming FASBA's accounting rules and providing clarity on how they should be applied. FERC has also issued a NOI and has launched a look at how virtualization and cloud services for power grid operations should be done. There's a white paper that was issued by NERC and FERC on SIP and looking specifically at cloud computing among a host of other things. Now, for us in New York, to date, New York regulation has remained consistent with accounting standards and guidance, and we have not sought to modify the accounting treatment of these contracts further than what was allowed under the Financial Accounting Standards Board's guidance. And in New York, no utility has so far requested alternative treatment or given the appearance of a bias towards traditional solutions. Our utilities are engaged in cloud services and it really is part of their IT strategy and their strategic strategy. New York does allow the capitalization of certain cloud computing implementation costs. Again, it is consistent with the Financial Accounting Standards Board's update from 2018. It's important to point out that New York does not typically treat other cloud computing costs as a regulatory asset. Cloud computing was discussed in our New York REV proceeding back again in May of 2016. And in this section of the order, the Commission was discussing the potential capital bias that results in utilities choosing to spend on capital investments over operating expenses in order to earn a larger return. Ultimately, the Commission at that time decided against modifying the treatment of capital and operating expenses at that time, but we did cite that prepaid cloud computing contracts give an example of a situation where a utility can earn a return on operating expense. To be clear though, this track 2 order and this example that was in there is consistent with generally accepted accounting principles, which is prepaid costs for cloud contracts or any other are typically included in rate base. So the order did not indicate that New York at that time was modifying accounting treatment of cloud costs. It is something that is a viable discussion. We're going to get under the hood a little bit about that today on whether states may wish to modify such cloud computing accounting treatment and beyond what FASBA approved. It is something that other states have grappled with. And so for us, it's about looking at what is important from a regulatory structure to help incentivize utilities to participate in these things that can, not always, but can give benefit to the customers. And how do we account for this in a prudent way? First, we're going to have as a panelist Joseph Santamaria. He is the director at Amazon Web Services, responsible for customer solutions and migration in Americas. Prior to this, he was chief information officer at PSEG, where he built the PSEG energy cloud platform. He was a former CIO at United Aluminum in Connecticut. He has worked in the pharmaceutical, consumer packaged goods, and aerospace industry. He has 2 children, and he currently lives in Princeton, New Jersey. Joseph?
Thank you very much, Commissioner Berman, and thank you, NARUC, for having us and inviting us to talk about this very important topic. If we can jump into my slides, that'd be great. Thank you. And can we? Great. So this is the agenda for today. My goal is relatively straightforward, is to, and by the way, my camera is not working, so I apologize. I won't be able to turn it on, but I'm not much to look at, so consider it your lucky day today. So anyway, my goal today will be to talk about 3 topics. One is introduction to cloud computing and a little bit about AWS. Most of what I'm going to tell you applies to all repeatable cloud computing platforms at this level of generality. So not not a lot in terms of taking you deep into AWS. I want to make sure you're comfortable with cloud, why utilities and other companies are selecting cloud, what some of the values are. We'll also talk about compliance and security. Obviously, every time you talk about information technology in the utility and the energy sector, you have to talk about compliance and security. And then we'll share a brief example of how we use cloud solutions at PSEG to establish the PSEG Energy Cloud, as Commissioner Berman just alluded to. So if we can please move on to flip a couple of slides forward. Thank you very much. So what is cloud computer? Cloud computing is, and Commissioner Berman also mentioned this, it's fundamentally the ability to provision technology services like compute, database, storage, applications through the internet. Okay, so most of you are, if not all of you, are already very familiar with accessing email through Gmail or Yahoo Mail or other provisions. All you need is a web server. You log in and boom, you have a mail capability. So cloud computing is the same very similar for IT services. Okay, so if a company has to stand up, for instance, an example in our industry would be an outage management system, and they need to provision a cluster of servers, let's say 20 servers with 2 petabytes of storage and certain memory parameters, and a database to run the OMS on. They can buy that today and get shipped to them. They'll rack it, it gets to their data center, they'll stack it, they'll connect the servers, they'll do the network configuration, and that takes some time. Or they can just go to the internet and provision that from a cloud provider, provision all the same set of services, literally in, I wouldn't say minutes, but certainly in hours. And then the other fundamental advantage is, with the cloud, you only pay for what you use, and it's a pay-as-you-go pricing model. Okay, in the on-premises model, the moment you sign the contract, those servers are, you just have to pay them, and you start, disbursing capital and other, financial assets. With the cloud, you don't until you start using what you provision. And there are minimal, you have options in terms of contracts, but you can also shut down those services anytime you're done with them, and we'll talk a little bit more about that. So if I can have the next slide, please. Thank you. So what's AWS? AWS, Amazon Web Services, fundamentally the world's leader in cloud. We're the most comprehensive and broadly adopted cloud platform. We have millions of customers, including small, fast-growing startups to the largest enterprises, many of them utilities here in the U.S. and abroad, many leading government agencies, and we offer over 175, close to 200 fully featured services that you would otherwise have to provision and buy services like compute, I mentioned before, storage, database, network solutions, analytics, data lakes, but also robotics, machine learning, artificial intelligence, Internet of Things, mobility solutions, virtual, augmented reality, blockchain. So we have, all those solutions. You can just log in through a browser or through what's called a command, but let's say through a browser. And with a few clicks, you can instantiate one of those solutions, and you can start innovating and building development or testing applications, or doing whatever you want to do for your business. The reason why, if we can flip on to the next slide, please. The reason why companies use cloud, and you probably heard that cloud providers are one of the fastest growing companies in tech right now, is threefold. One is better capital and cost reduction, so better usage of financial resources. We'll talk about that in a minute. The other is you can sense already it's very agile. It's very much more productive to log into a browser and provision through a service that's already pre-built and it's ready to be consumed, versus having to go in and just go through the pain and the effort to set it up in your own data center. And then all that flexibility and this productivity allows companies to innovate and transform their digital layer much faster. And we'll talk a little bit about that as well. The flexibility that the cloud offers comes very handy when, for instance, companies are trying to do a data center consolidation. Okay, they want to reallocate capital. They don't want to invest in their data centers, which are increasingly expensive, and instead they shift their workloads and their systems to run on the cloud. Could be that you have a co-location or you're already outsourced, but the contract changes and you want more flexibility on your contract, so customers come to us for that as well. Or just simply an acquisition, some M&A activity, there's an acquisition or divestiture, so you need to be able to provision quickly, a lot of compute power, a lot of solutions, and you can do that in the cloud very easily and in a very agile fashion. Let's just move on to the next slide, please. So why, how do you increase agility and developer productivity, and why does the cloud do that? So clearly, I mentioned earlier in our OMS example, the need to receive that equipment, rack it, stack it, connect it to cooling, connect it to power, plug the storage and configure it and patch the servers. So all that is done for you in the cloud. So all that stuff, you can reallocate them to daily higher value work. So instead of building the infrastructure for the OMS, you can reallocate them to configure the OMS or to build more SCADA points in the OMS, or just closer to the customer services, and you can do that very easily with cloud. You have, I also mentioned some of the services like augmented reality, machine learning, blockchain services that if you wanted to experiment and you wanted to have an idea on how to, for instance, detect leaning poles through image recognition. Well, if you had to build that concept internally, you would have to build a high performance computing cluster in your data center. You have to spend a lot of money, and you'd have to likely get it approval through business cases, and it'd be a long lead and a long cycle to get to that point. With the cloud, you can provision. If you have a concept, you have an idea, you have some images you wanna try with, you can provision in the morning and try whatever you're trying. If it works, great, you can continue scaling. If it doesn't work, you shut down and you stop paying. So you can create momentum to grow new skills, explore, experiment with new processes, and really try things that otherwise you just could not afford to try. And that the flexibility and the invention that this brings is it's really a game changer for IT departments and for solutioning in all over the world. That's that's a key driver for companies who are trying to get better at building a digital muscle and get better with technology, and they want to do that in a very experimenting and trying things out and doubling down on what works and shutting down what doesn't work without having to lay out huge capital investments up front. Cloud is a perfect answer. It's a very good answer. If we can move on to the next slide, please. So from a financial standpoint, right? So let's continue with our OMS example. So if your utility is ready for or needs to upgrade their OMS, so what are the things that are going to happen? First, if you do it on premises, you're going to have to buy the equipment. And when you buy the equipment, the first thing you're gonna be asked is, well, what's the peak number of users, right? And the utility is gonna look at, well, what's the biggest storm we had? How many mutual aid crews we had? How many operators did we, that we bring in at once working overnight? They're likely gonna add a buffer, 20%, whatever it is for margin of error. And they're gonna buy that. They're gonna buy that fixed capacity, and they're gonna be paying for that for the next 10, 15 years, right? With the cloud, you frankly don't even have to scope this if you don't want, but with the cloud, you have the infinite elasticity, and you can provision servers for your regular day, let's say 200 users, and 2-3 days before you see a storm it's coming up, you can provision for 10 times, for 100 times, for 1,000 times, your regular load with a few clicks. And so tremendous flexibility. You can do that in hours. We never recommend doing that the day of the storm, but the point here is you have tremendous flexibility, and you can scope to your regular workday, and your payment and your resource allocation mirrors your demand and your need at any given point versus buying and committing to peak capacity. There are also many flexible purchasing models that we offer in the cloud. You can do on-demand purchasing. If you have a workload that you're comfortable you're going to need, you can do what we call reserve instances. So you can prepay. There are different models that, based on your willingness to commit, based on usage, will give you different ways to buy and to pay for those assets and that compute. There's no upfront capital, which fidelity should be very attractive, because you can redirect technology and server capital to, frankly, pipes and wires, which is where we want to put, you want to put those dollars, because again, that's all provision. It's already bought. We've already spent, cloud provider has already bought that equipment and is ready for you to lease. And then we continually optimize costs. We provide many reports to customers about usage. We make recommendations to customers in terms of how to save money automatically. We have some of our storage solutions. If the customer gives us permission, we'll move documents and files that are not being used to lower cost storage tiers. So we're constantly optimizing costs for our customers. We do free of charge, a cost optimization workshop where we look at logs utilization. We make a number of recommendations for our customers. So we're constantly optimizing costs with cloud, because again, it's a flexible model. You haven't, you're not committed to anything. Frankly, you're committed to using what you need. If we can move on to the next slide, please. Thank you. So on the this is an example, right? For instance, for how utilities and companies all over the world are talking about data and how to get better insights into their data. It could be product data, it could be customer data, it could be electric grid operational data. And how do we, it's very easy in the cloud to provision business information systems and data analytics systems, whether it's data lakes or Hadoop clusters to do massive analytics. Many of our customers, some of our customers do genome sequencing in the cloud, and those are tremendous amount of resources that get provisioned for a short period of time and then get released back, and the charges stop. So the ability to instantiate, bring these huge amounts of data, petabytes and exabytes of data, smart grid data in the cloud can handle and absorb them with at that scale will really allows customers to really get insights and put resources to work to get insights to a depth that they would have never been able to afford internally, and to do that very fast, right? Many of our customers use that to deepen their relationships with their own customers, and to reduce business risk, because you're not committing to that level of investment, that level of tying those capital dollars. If we can move on to the next slide, please. Thank you. We'll move on to security. So how does cloud enhance utility security? We are, at this point, I think most analysts would agree that the cloud solutions are safer than on-premises solutions, and there's a number of reasons for that. One is the visibility and the control we offer our customers. We have a tremendous amount of logging. Logging is tracking activities that are happening within a customer domain and within the cloud. We have alerts. We have default responses that we automate. and are very easily set up. So customers also are very, they have very good visibility into what assets they have in the cloud, who's using them, how are they being used, what hours are being used, what data is in them, how is the data moving around. So there's a lot of visibility and controls that can be put in place in the cloud. Many of them are automated, as mentioned, including responses that can be pre-configured and set up to specific events. So you don't need to have someone constantly monitoring. We also have plenty of partners that are building, most cloud providers have what's called a marketplace. So we offer not only our own products, but similar to the App Store in your iPhone, if you will, you can go and provision solutions from partners that are very innovative in terms of security, and you can provision those, pay for those, and install those in a matter of hours, compared to having to do that through an internal on-premises deployment is much faster and simpler. And obviously we have the highest standards for privacy and data security. If you can flip to the next slide, please. We are, thank you. We get audited all the time, and we built our infrastructure to satisfy the strictest requirements, security requirements from military, global financial institutions, and healthcare and other high sensitivity organizations. We have a number of, you can see some of them here, internationally recognized certifications, accreditations for security and cyber. We are audited by our own groups. Our own cloud security experts are auditing our cloud all the time, but needless to say, our customers are also auditing us all the time. So this is great for customers because it's a shared, the processes, it's a shared infrastructure. So while every customer has a virtual data center within the cloud, there's the data center is the same. So many of the audit results are and audit improvements on security are benefiting and inherited by all our customers. So we also produce assurance reports for customers that they can access through their management console through the internet. That talks about our security. We also train our customers in products and services that that require cybersecurity certifications and knowledge. We invest a lot in cyber, and we make those trainings available to our customers. And then I'll just highlight a couple of our certifications that we meet. It's the highest standard is FedRAMP High, which we meet through our government cloud service, but we also all our commercial regions in the United States meet the FedRAMP Moderate standard, which is pretty strict, as probably well aware of. If you can move on to the next slide, please. Having said that, you're familiar with the shared responsibility, being in the industry we are in. So there are a number of security activities and requirements that fall within the customer, and but every activity within the data center, whether it's patching, networking, making sure that the physical separation between the different layers, between hardware, software, networking, that access controls to the data center, the location of our data centers is kept secret. So all of that is within our purview, and the customer will manage areas like, if you can move on to the next application. Customer will manage stuff, for instance, like identity and access management. Right, the installation, if there needs to be in the example of OMS, if there's an OMS patch that needs to be applied, customer would apply that. The customer would also make sure that the right individuals have access to the right data in OMS at the right time, and that they get deprovisioned when they get revocated when they don't need it anymore. So there are some of the security activities fall within the customer customer responsibility. We also have a number of tools for detection of events, and not only events and threats, but also misconfiguration. If a customer misconfigures something, we typically will pick that up and we'll notify the customer that there's a misconfiguration, that something may have been globally set up to be open to the internet, and we'll notify customers about that. We also have many reports and automatic agents that look for unexpected behavior and notifies customers of that. And we we manage that as part of our standard offering in the cloud. We also have a number of infrastructure protection. I mentioned some of those earlier, but we manage the perimeter data flows. We do vulnerability management and patching. We we ensure that within the boundaries of where the customers has entrusted it, which is within our data center, so to speak. We manage all the security, configuration, and maintenance, hardening, and all the way up to, depending on what the service is. For some of our services, we go all up to the software service, like for instance, for our machine learning or our blockchain solutions, that we would, our security responsibility would go all the way up to the application. If you come and you just provision from us, a database service, our patching and security would go all the way up to the database, and you'd be responsible for, the customer would be responsible for the application. So it depends on at what point the customer provisions the service. We're responsible all the way up to that point, and after that, the customer responsibility comes in. Data protection is something also I want to mention. Customers own the data at all times, and our data is, we offer different encryption solutions for customers, all the way to an ability for a customer to bring their own encryption key. So AWS would never have access to that data, and being able to unencrypt that data. The customer has encryption key, and we don't have access. Data is encrypted at all times, on at rest and in transit, making it unintelligible and preventing unauthorized access to it at all times. And then finally, even with extremely mature and preventive detective controls, at times things happen, and we have in place a number of incident response mechanisms to work with customers, provide insights, do forensics, detect those and respond in a way that is expeditious and effective. So if we move on to the next set of slides, please. We so at PSEG, right, I don't need to tell you this, what's coming over the next few years with the electrification of transportation, the focus on sustainability, the introduction of distributed resources, the ever-increasing expectations on the customers in terms of tailored and frictionless experiences. This will require utilities to rethink their electric power value chain and how they build solutions and their digital muscle. So in order to face this future and to face the responsive grid and the flexibility that the grid of the future is going to require, there's going to have to be, and utilities are working already on this, a pervasive, intelligent set of digital networks and sensors that gather data, feed that data back to the utility operators, and the utility operators have the solutions and the insights to be able to react and manage that grid. That is it's gonna be increasingly complex. We're going to a networked grid with multi-flow, multi-dimensional flow versus a linear grid. That's what's traditionally been, right? So one of the things we wanted at PSEG was to really build our technology and our digital muscle to start building the grid solutions and the customer solutions of the future that would deliver, would sustain our environmental and economic goals at the state, and would provide new customer experiences that eventually would help us engage customers better and get to know our customers better, and fundamentally be able to offer them services, whether it would be clean energy or energy efficiency services, that would support the regulatory goals that we had in our service areas around RPS and other goals. So if you can move on to the next slide. We started to build what we call the PSEG Energy Cloud, which is fundamentally a cloud of a collection of solutions, one of them being AWS as a provider of cloud services, to manage the electric grid of the future, being able to use services like machine learning or big data to analyze the data we're getting from connected devices to better manage the needs of the grid, better manage the operational needs of at any given point, and automate as many interactions and decisions as we could. Use the intelligence, getting better sense for opportunities to optimize energy consumption and drive sustainability, and then fundamentally offer our customers a better experience, as I mentioned earlier. If you want to move on to the next slide, I'm not going to spend a lot of time here, but fundamentally we had a number of devices, whether it's smart grid devices, AMI, to electric vehicle chargers, to smart thermostats, all the way to connected recloses, Alexa, mobile apps. All that, excuse me, feeds data to the energy cloud platform, and that data is being utilized then by operators, being utilized by solutions in customer relationship management to offer new products to customers and interact with customers better and anticipate the customer need and tailor some of the offerings that the customer has, and build a number of solutions on top of that. So if you can flip to my next and last slide, please. Thank you. So these are some of the solutions that we either built or we're looking at building on the energy cloud platform. So next best action platforms for customers to pool data around their consumption, around their preferences, their aspirations, and really interact with them in terms of offering them better advice and better services on a proactive basis that would be more insightful and also lower cost to serve, because there would be primarily digitized services. Detection of outages in real time, getting a bunch of IoT data for demand response, and getting to know the real time operations of the grid and distributed resources on a real time basis, and providing, I mentioned earlier, services like AI and image recognition for pole detection or asset management, using augmented reality to provide better information on underground assets to our crews for digging or just regular maintenance operations. So there are a lot of opportunities that having access to a cloud provider enables. If we had to, as a utility, had to go and invest and buy solutions for augmented reality, machine learning, IoT, and all the things that are linked out here, it would just be cost prohibitive. With the cloud, we have an ability to build them and just pay them when we use them, which makes them affordable, and it allows us to offer services that otherwise we would never been able to, PSEG would never been able to afford. So with that, I conclude my remarks. Thank you very much, Commissioner Berman. Again, I'm back to you.
Thank you so much. It's very helpful. I think from my perspective, listening to a lot of what you were saying really talks about the benefits and some of the risks. So when we look at it, we're looking at, especially with your example with PSEG, about the opportunities that may be available. In New York, many of our utilities are using cloud services in many different formats. And part of that strategy of using it is for cost savings, process efficiencies, speed to market, redundancy, or resiliency. And the cloud helps on expanding capabilities and really gets into some of our policy issues, like looking at the visibility, how to use those data analytics, how to help the customer, how to deploy new technologies like EVs, also looking at things like electric and gas system peak reduction using AMI. And then the benefits also need to be balanced against the risks with data security and data control concerns. And that really also takes it back to the economic regulator, who is also weighing not only the fiscal accounting treatment of it, but then also as we are looking at what to do with some of our policy initiatives and how we may enable the utility and the industry to work together to roll out some of these things. What are some of those things that are important? I'm going to now turn it over to Rick Cutter from Cloud for Utilities. He has over 20 years of experience managing the delivery of technology solutions for utilities. And as a managing director for Cloud for Utilities, Mr. Cutter has established the Cloud for Utilities strategy in collaboration with Mr. Snide. Mr. Cutter brings a realistic view of the needs and concerns of this industry, especially as it relates to cloud technologies. And for AAC Utility Partners, of which he is a co-founder, he leads implementation strategy planning and client team implementation support team. These services are delivered for on-premises and cloud solutions exclusively to the utility industry. In addition to his on-premise utility software experience, he has also managed the first cloud SaaS SIS model for the utility industry. This business model was a variable price model service based on consumption without license fees. The business focused on the emerging deregulated energy markets in the late 1990s, and in those early days, the model was referred to as ASP, Application Service Providers. Rick?
Thank you so much. That was probably a longer intro than I deserve, but I appreciate it very much. A little bit about our organization is we're very focused on the utility industry and helping utilities become educated and build strategies for moving applications from on-premise to cloud. I think a couple words you'll hear me say today that repeatedly are scalability and elasticity. And what I mean by those comments is in a regulated model, utilities obviously are compensated for rate of return on capital assets, for the point of our discussion today. And because of that, they're always running projects in IT. So they have to buy assets to account for their peaks. So we believe that probably incentivizes them to sometimes overbuy, whereas in a cloud model, they buy what they need, and what they need can change up or down based on projects. So just want to make that point at the beginning here, and we'll talk more about it at the end. So let's go to the next slide. And you can skip this one as well. Let's talk about the cloud economy. This is fairly new, but we're getting into a decade of it, at least I would say, in the non-utility space. The cloud economy, as I'm putting it here, is pretty much here to stay. This is not a fad. We're going to be seeing cloud computing solutions for quite some time. There's even talks of applications that can be built in the cloud that we would not be able to purchase and put on site in your local data center. I think Salesforce would be a great example of that. Recent reports show that in 2020, the market could be $371 billion, could be $832 billion by 2025. That's rapid growth. Work from home has really also driven people to use more cloud products and services. And companies that really were already using cloud, the feedback is they were able to make the transition to work from home with the COVID-19 situation fairly quickly. So one of the not planned on benefits of it, obviously. In many organizations, IT budgets have been reduced for 2020 due to the economic environment. However, Gartner recently estimated money spent on public cloud could rise as much as 19%, even with the overall shrinking budgets. I think that's an important economic factor for us there. Okay, next slide. Some of the trends in cloud, and there's a lot of different things to cloud. You heard our friends from Amazon talking about different components of that. I won't dig down into that, but the various models, I would say probably just about every major utility, maybe even in the small and mid, as well as tier 1 utilities, are using some form of cloud today for different things, because there are different models. The trend is toward multi-cloud or hybrid cloud. And what that means is basically they may have multiple cloud providers for different components of their technology environments. Hybrid cloud means they could have some things in the cloud, also some things on premise, and have a mixture. I expect that'll be the model going forward for some time. There are increases in cloud spending, as we talked about before. We're having more and more workloads migrated to cloud as an IT and customer service applications as well that are being consumed instead of being on-premise systems. And here's a quote from IDG. They've estimated 81% of organizations have at least one application in the cloud today, up 73% from their last metric in 2018. And again, COVID-19 has definitely accelerated what we're seeing with cloud computing. Next slide, please. Cybersecurity continues to be a concern. People are having to enhance their cybersecurity strategies to include the management of their cloud environments. It is a partnership with their technology providers and themselves on how they manage the configurations of cybersecurity. Knowledge of security configurations is important with their cloud partners, and working from home now has become a new extension of people's cybersecurity infrastructure. So we're seeing people shift on how to also include employees bring your own laptop to work based on their home environment as well. So that's becoming sort of their wide area network. And also, we had an interview with a gentleman named Stephen Bernard a few months ago, who was the chief security officer over at Sony when they were hacked by a third party. And one question is, how do you handle being attacked by a nation state? We're seeing more and more of that, unfortunately, these days. So one thing to consider is when you're looking with these large firms that are providing these cloud infrastructure, they're very focused on cybersecurity, building technologies and so forth. We believe that's an advantage for our utility infrastructure since that is their core business. Next slide. So if you look at some of the applications of cloud computing, this is just a small list of those items. On the left, we're seeing people do what I'll call digital bolt-on applications. So with their legacy system, we're seeing a trend right now, especially with, I think COVID-19 has accelerated for more customer self-service apps over the web, where utility customers can log on and not just pay their bill, but initiate different types of transactions that would take work away from the call center, which is a good thing. And we're seeing a lot of people now, there's many competitors out there now with SaaS, software as a service applications that can be bolted on to their legacy systems. So that is a trend we're definitely seeing. Mobile work management, customer relationship management for more deeper understanding of their customers. In the area of big data, that's one that's being used, I would say, by many utilities to expand their storage capacity needs when they need it for an elastic model. Software as a service, ERP, big financial systems is very popular with the software as a service model. Customer information systems are being hosted now as SaaS customer as a service model, where you just pay for what you need based on your number of meters or customers. And we're seeing a lot of clean energy programs being put into the cloud, which is quite interesting. DER management, dynamic load control, EV charging optimization. These things are pretty critical to continue the adoption of the model. Next slide, please. Next slide. Thank you. So some of the challenges, I'm sorry, one back, please. Some of the challenges out there for utilities today in regards to general implementation of systems. Number one is interoperability of systems. We still have a lot of older legacy systems out in our utility space. Those systems are large projects to replace at times. They're complex and in-house, so utilities are being very cautious when they do upgrade those systems. So I think they probably are lagging behind in being current in some of their systems and other industries. Those legacy systems are very fragile. So they're typically hard-coded applications where they have an army of consultants sometimes to make changes to them. So it can be difficult for them to implement newer changes required in their particular territory. Modern infrastructure is a little more complex than legacy systems that are like mainframe, very singular focused, which I think is one advantage of cloud, because it takes some of that technology away and puts it on the burden of the cloud provider. And retraining technology staff for these new models is important as well, and creating challenges to our industry from technology. And of course, we have the aging workforce and utilities in general. Okay, next slide. Some samples of firms just based off internet Google search I did that are utilizing the cloud, which I thought would be interesting. Zoom, which I think we're all using, or some form of that technology like we're using WebEx today. Zoom is being hosted in the cloud. Salesforce is a cloud only or a SaaS only application that's being hosted. Netflix, FedEx, very large companies, and government. You heard government being discussed earlier. The government is moving many applications and services to the cloud as well. So as I started out, this is not a fad. This is definitely a trend we're seeing that we think is here for the long term. We're probably, all of us are using some form of cloud already. If you've got an iPhone, you probably have the iCloud backup software, which is basically a form of an individual cloud utilization. So we're using it today. It's gaining momentum. It's here's a big part of our economy going forward. And I'll start back with where I started. Keywords to remember: scalability and elasticity. I think that's one of the biggest advantages for us. So our utilities don't have to overspend for peak. They can scale up, and their systems can scale down elastic as they have those needs for bigger projects. Next slide. So we did a survey at the beginning of the year back in February, and I've given a couple of slides just to show you sort of the understanding regarding a rate of return. 152 utilities responded back in February. I would probably venture that some of these answers might change if we did it now that we're in the middle of COVID-19. Let's take a look at the next slide, please. Next slide. Thank you. So the question here was, the regulating body that oversees my utility allows for a rate of return. And 23% said yes, 24% no, 16 said considering, and some of them just didn't understand if the regulating body was doing that or not. The next slide here, I think, talks about if they're being impeded on the, thank you, if they're being impeded by lack of a rate of return. So basically, my utility has made the decision to use on-premise solutions over cloud because of the inability to earn a rate of return. 58% agreed. So I think, one concern I have is that there are many instances where a cloud solution would be superior to on-premise, but we're probably incenting utilities to make a capital expense because of the accounting side of it and the rate of return. I think that's one of the key messages that we think is important to be considered by NARUC and all of our utility organizations. Okay, next slide. So that's the end of my session. I appreciate your time. Thank you so much for having us participate. I went a little faster than our Amazon friends and look forward to any questions at the end. Thank you.
Oh, great. Thank you so much. That was very helpful. When I look at this, I really think it's important for folks to consider there are really a couple of buckets. One is the fiscal accounting bucket, and then the other is what is the benefit that is trying to be done from cloud computing, and then what are the barriers to that, and does a regulator and does the regulated entities that is working with the regulator, do they look at this in terms of the policy objectives and being impeded, and how do you also still handle the prudent fiscal review that is needed? And then the core issue, which really goes beyond cloud computing, is that data security. Rick mentioned the foreign actors that have to be looked at, and then how do you do this in a scalability perspective so that it does give an economies of scale. Next up, we have Danny Wagner. He's a director at Advanced Energy Economy, where he manages AEE's regulatory work in New York and engages at public utility commissions in several other states on a range of utility business model issues, such as performance-based regulation, performance incentive mechanisms, and equity in the regulatory treatment of capital and service-based solutions. Prior to AEE, he worked on electricity policy issues at the White House Council on Environmental Quality and Third Way, a think tank. Before working in the energy field, Danny worked at the Center for International Private Enterprise and the U.S. Chamber of Commerce on international corporate governance and social responsibility issues. He is a bachelor's in government from University of Texas at Austin and a master's in science and technology policy from George Washington University. Danny?
Thank you, Commissioner Berman. As Commissioner Berman just said, I'm Danny. I work for Advanced Energy Economy, and AEE is a national business association of companies that are working to make the energy system cleaner, more reliable, and more affordable. You may be asking yourself why a group of companies that provide clean energy products and services is interested in cloud computing. Several years ago, a lot of our members that provide services through cloud computing started mentioning that they were having trouble deploying those services at utilities. Those services include energy efficiency, demand response, EV charging optimization, direct load control programs with thermostats, and the list goes on. They started telling us that they were surprised when utilities didn't want to use their products and services directly from the cloud. Instead, the utilities wanted to buy the software and run it off their own servers. This would be a greater expense and effort to utilities and typically runs counter to what we see the rest of the economy adopting, which is direct use of cloud. We then developed a better understanding of the regulatory and accounting issues that created this financial problem for utilities. As Rick mentioned in his presentation, many utilities are dissuaded from investing in cloud computing because it is a service, an operating expense, and not a capital investment. On to the next slide, please. As most of you are aware, when utilities invest in capital, they make long-term investments for which they're paid back via rates with interest, their return on equity, and that's how they get the return on the money that that the shareholders invest. So that's the reason why shareholders invest, so that they can make the necessary market return to provide that capital to utilities. On operating expenses, on the other hand, utilities do not earn a direct rate of return. Instead, the opportunity for the utility is to manage their expenses and spend less than their projected expenses, and they get to keep some portion of that savings. If they overspend, on the other hand, compared to projections, then they will make a loss, or that will eat into their earnings. So the effect is largely the same across the implementation of cost of service. I'll show you on the next couple slides how this works out. So this shows the standard model of cost of service without any clawback trackers or capital trackers. On the left-hand column, you start with how the revenues and expenses look right after a rate case. The revenues match the expenses pretty well. And I'll just mention that this is a miniature utility revenue requirement where the IT expenses are a disproportionately large portion of it. But the middle column here shows what happens if a utility avoids a $4 million on-premise investment that comes out of their capital budget, and then it goes down to it gets converted into a cloud expense. Let's say it's cheaper, $1 million cheaper, it's a $3 million cloud expense that then goes into the operating expenses. And because of that, because of the $1 million savings on the expense side, savings are generated, the revenues remain the same, and so the utility is actually generating some short-term earnings from its savings and expenses. Even though the imputed ROE goes down, the utility is actually benefiting here, and customers are benefiting from the cloud computing. However, in the long term, let's go on to the next slide. At the next rate case, the revenues are adjusted to match the expenses. So the revenue goes down. The savings, which the utility was retaining as earnings, those go, and the utility is left with the return on equity, which is smaller than where we started out with. So in the short term, the utility made some money based off of the savings. In the long term, the earnings off of the capital is diminished. Let's go on to the next slide, where we look at the impact of a capital tracker or a clawback mechanism. So capital trackers will adjust the revenue up and down based on actual capital used, while the clawback mechanism will only do a downward adjustment. So there aren't operating expense trackers. I've never seen them in use at utilities. And so what we have is an asymmetrical adjustment here. So the way this turns out, in the middle column, we have the on-premise system that is being removed from capital. Also associated with that, the revenue is adjusted down by that 4 million, and it gets added to the expense side. So we have a downward adjustment on revenue due to the decrease in capital. The expenses go up, and there's not a commensurate increase in revenue due to the expenses. So in our tiny revenue requirement example where the IT expenses are disproportionately large, what happens here is the utility is actually losing out. The revenues do not meet expenses, and the imputed ROE has decreased. In the long term, what will happen is that the next rate case, the revenue will go up to match the prudently incurred expenses, and the utility will no longer experience a loss, but there still will be the decrease in return on equity relative to where the utility started out from. So moving on to the next slide, what this shows is that regardless of this specific implementation of cost of service, the utility's strategy is really to grow durable, dependable earnings over the long term through capital growth. Expenses produce short-term earnings or short-term losses, but the impacts are short-lived. And this is particularly acute for a service expense like cloud computing, because it replaces capital. It provides an opportunity cost for that foregone earnings on capital. And then it also increases expenses and makes it more difficult for the utility to generate short-term earnings through appropriately managing those expenses. On to the next slide, please. So some regulators have recognized that the regulatory model can create divergent financial impacts for utilities and their customers. What may be good for the customers may not be good for the utility. This puts more burden on the regulators to review complex IT investments to ensure that they are the best option for customers. Instead, some regulators have decided to allow utilities to treat cloud as capital to resolve the financial trade-off that utilities face when they consider cloud-based solutions. And so the premise is to provide equivalent financial impacts from on-premise and cloud-based solutions so that the utility can choose the right solution based entirely on merits and not the regulatory accounting treatment associated with a specific solution. And the way that this has been done in most states is to capitalize the solution, the cloud-based solution, either through a regulatory asset or a prepaid service. And so the utility pays for it upfront many years in advance, and it is amortized in the rate base over the life of the service, just like you would a distribution asset. The problem here is that this doesn't always jive with the cloud computing flexibility. So cloud services are charged based on usage, which Joseph explained. They'll go up and down, and you will be charged accordingly. Prepayments require you to lock in a certain service level and to project that over time. One benefit of Illinois' draft rule, which was not approved, but I'll explain that a bit more later, was that it allowed periodic payments to be capitalized so that the utility could continue to pay as it uses a service and not have to predict it up front. And I'll show you an example on the next slide. So the blue line at the top represents an on-premise system. You have to build it first to be able to use it, and that is a durable asset, and you have to plan the peak for your highest usage among these 7 years in this example. So that requires a lot of prediction, and you're locked in, and you could very easily overbuild and have that expensive asset underutilized, and customers would be paying for it. With a prepaid cloud service, you can escalate it over time, as the orange line shows, but you could still overpay, and customers, their usage may be lower, and you're still paying for what you estimated. The actual usage here represented in the gray line goes up and down, and your payments would go up and down. And if you use less, you pay less. If you need more, you pay more. But overall, customers are just paying for what they utilize, and that is one of the key benefits to customers. And so that I think one of the most important things is to preserve that flexibility. Moving on to the next slide, another issue that came up for states that considered capitalizing cloud computing is what costs should be capitalized. As Joseph explained, it's not just software as a service. That is one aspect. You can also have storage only services like Dropbox is an example. You have hosting, connectivity, computational applications. And what some states tried to do is say, okay, if you can capitalize this cost for on-premises systems, you should be able to capitalize it for cloud systems. But as it turned out, while the ends may be comparable between on-premise and cloud-based solutions, the means for getting there are not always the same. And so it's very difficult to draw that one-to-one comparison for costs. And so instead, the states that have looked at this have gone down the route of a more simplified process. Illinois' draft rule allowed 80% of cloud costs to be capitalized. So utilities in the state, for their on-premise systems, they historically, on average, the costs of the system were 80% towards capital, 20% towards operating expense. And because the on-premises system represents the opportunity cost of the utility, what would they have earned had they invested in the on-premises system, they decided to use that 80% and apply it to cloud. In the draft rule, as I said, it was not approved. In Alabama, what they decided to do was to allow the utility to capitalize all cloud-related costs. Also, Commissioner Berman previously mentioned the change in the generally accepted accounting principles adopted by the FASB board. What that was, it allowed utilities to capitalize their implementation costs. So those are the things that the utility needs to invest in over the long term to be able to use the service, such as training or conversion of databases. It's not the actual solution itself, but it's just the changes in-house that need to be made in order to use that solution. And so the FASB adopted a rule aimed at the economy at large and for mostly competitive companies not under cost of service regulation. And it was not meant to address the incentive associated with capitalization. So it did help in terms of the implementation costs, but it did not address the cloud solution itself. GAAP rules, though, do allow regulators to create regulatory assets and capitalize them for whatever purpose. They recognize that commissions have policy goals, and the GAAP rules allow commissions to create these regulatory assets for whatever whatever reason they see fit, and it's perfectly in line with financial standards. Moving on to the next slide, it's just a summary of what some states have done with cloud for utilities. New York was a first mover, but as Commissioner Berman said, it was more of a clarification of what utilities could already do. They confirmed that existing accounting rules allowed utilities to prepay software licenses and for them to be capitalized. In Pennsylvania, before FASB made that determination on implementation costs, the commission there allowed utilities to capitalize their implementation costs. They have also granted the capitalization of cloud solutions for specific utilities and rate cases. Illinois had the most extensive process to date and came up with the most, I guess, well thought out rule to date. And the draft rule allowed for 80% of costs to be capitalized and for payments to be made flexibly or to be prepaid. The rule in the end was voted down. The commission that had the final vote was very different than the one that started it. And they made a judgment call. It was their prerogative. They decided that utilities were already using some cloud solutions, and they found that convincing. And there are a lot of other, there's COVID and other crises in Illinois that just was not the right timing for this to move forward. But they do allow utilities to propose capitalization of cloud computing in the future. In Ohio, the PUC made a general statement that it was in the public interest, and they invited utilities to propose capitalization in rate cases. And in Alabama, the Public Service Commission there provided enduring authority for utilities to capitalize cloud and related costs on an ongoing basis. So with that, I'll end my presentation and hand it back to Commissioner Berman.
Thank you so much. That was really helpful. I asked the NARUC folks to keep this slide up because I think that this is really a very important slide. From my perspective, it also goes back to that NARUC resolution back in 2016, which recognized that this was an important topic, but it was also something that there was not one size fits all, and that it was important for regulators at each state to work with their regulated entities to identify what was appropriate or not. Really comes down to looking at the fiscal implications. It comes down to looking at what prudent accounting is, but it also comes down to what the ultimate goal is and what your policy objectives are and how they may or may not be helped with certain technologies like cloud computing. I do think it's important to note that for many folks, after New York acted in 2016, there was a flurry of folks thinking that New York was really a mover and a shaker in this cloud computing. And really, it was a clarification of us following the existing accounting rules, and also a recognition that we were open to looking at whether we needed to expand that. For us, also, the bottom line was, how does this fit for consumers? What are the benefits? What are the risks? And then dealing with many of these issues are also in other proceedings, like data ownership, like cybersecurity, like innovation and technologies that can help with that. I will mention, though, that Illinois, I think, has been really interested of late of being very focused on considering consumer impacts overall as we move forward in the future grid. And I do understand that there was some, from public reading of articles, et cetera, seeing that there was some tension in that stakeholders had felt that this 3-year process, they were going to come out with a different outcome. But I think what is really important to note is that it is an ongoing dialogue, and it is something that Illinois was taking a step in saying, yes, we hear you, but we also have to consider this consumer impact of cloud software. And it actually didn't stop things. It actually asked for the ability for folks to prove the use case more and to look at what is important. New York has, I kind of look at it as the buckets that we fall into is that for utilities, our utilities are, like many other utilities in other states, using in some fashion cloud computing, whether on premises or off, and that for them, the question and the challenge really lies into how do they have, when they're laying out their strategic decision making, how do they get away from looking at it purely from a financial accounting perspective, and then what's the appropriate cost recovery. Those are things that we as regulators look at in our prudent prudence review, as well as when we're looking at it in potentially a rate case, in terms of how is this helpful and how can we help to incentivize if it's appropriate, and what exactly does this these implementation costs, what do they actually capture? As we saw from the different panelists, we look at things that might be outside of the normal implementation costs that are also a side benefit. From looking at it also is from the vendor side of things, is that they really are grappling with their services that they're offering, and also understanding that this cloud-based solutions can be a very long process working with the utilities IT departments, and can be at times cumbersome and consuming, particularly for the smaller organizations. There is no standardization, even within my state, on a lot of these cybersecurity and IT requirements. It is something that can vary by utility nationally and in New York. And it also is from the perspective of the consumer, is also very important to look at, is this beneficial? How does this help? How is my data protected? And how can we enable this in a way that helps with some of the state energy policies that may be out there? Before we go into Q&A, I wonder if any of the other panelists have a comment to anything they heard, and then we can go into some Q&A. I do have a number of questions from various folks. Okay, hearing none of the panelists, I'm going to assume that you're good. If you want to incorporate some follow-up in your questions, in your answers to some of the questions, feel free to do that as well. One of the questions that I think is important is, and I'm going to read it verbatim, many in the industry believe regulators should offer utility incentives to pursue non-capital solutions, from cloud computing to non-wires alternatives, when such solutions are lowest cost. But aren't utilities already required to select lowest cost solutions via the reasonable person approach to prudence decisions? Please explain the rationale for paying incentives to get utilities to take the actions they are ostensibly required by the regulatory compact to take anyway. This is a really good question. There are other questions that came up that really fall into the same bucket in terms of the why are we doing this? What's the incentive? Danny?
Yeah, I'm happy to take this one. And I think it brings up a really good point that utilities are supposed to take the least cost option. And you know, it brings up this this rub, right? You know, if you have diverging financial impacts for customers, if they benefit, but then the utilities don't benefit, then you create this problem where the utility has to work against its objectives as a business in order to serve customers. And I think that when you develop that disconnect, then it creates a greater burden on the regulatory process to resolve that disconnect. And you have to have the necessary information and expertise to know, well, should they be building this on-premise system, or would it be cheaper for them to do it as a cloud computing solution? And it may not always be cheaper for them to do it as cloud computing, but I think that you know, a lot of times it would be, but it should be the incentives that we provide them should be to do what's in the best interest of customers. And so when there's that disconnect, then you have to have the right people, the right expertise to know that that's not happening. And I can give an example, I guess an anecdote. I got a call from a named utility at one point where they said, you know, I'm facing building this 8-figure on-premises system in an unnamed state, and I wanted to do cloud. My board didn't approve it. So what are the regulatory options for figuring out how to make this better investment in cloud. And so that comes up, and utilities will not always go for their business interests. Sometimes they'll go for what's in the customer interest, but we have to realize that sometimes things will not go that way when there's a financial incentive to do the other thing.
Thank you. I think that's very helpful. You know, I also want to tackle answering this question, because I truly believe this is a really important discussion, because it really gets to the heart of the issue, which is, why does a regulator need to incent or disincent a utility to do anything? And for cloud computing specifically, and for other activities that are similar to that from an innovative technology perspective, the answer is multifaceted. One rationale for providing an incentive would be to help transform the mindset of the utility from investing in capital-based alternatives that could add to their rate base and rate of return. But let's take a non-wires alternative as an example, because the question did also raise NWAs. And the best outcome for ratepayers is not as simple as the utility picking the least cost solution from a menu of options. If it were, there would be frankly little justification for the incentives, and the question would be answered simply. We do need to be mindful of what the goals are when we look to innovative and out-of-the-box solutions. There are true reliability questions we have to address. There are reliability trade-offs and concerns that may arise. And there also needs to be an examination of what a vendor's utility experience is, because there may be little to none and it may not fit neatly. To me, success is truly dependent on the ability, the utility investing their financial and human capital into identifying appropriate situations that are viable for NWAs, whether it's cleaner, cheaper, and more reliable, and where a regulator sees one as primary to one that may be more beneficial than the other, and making them all work. So incentives for performance or beneficial outcomes can help support this challenging work, but an economic regulator should never leave off the table that fiscal prudency that is necessary, and also ensuring that the benefit to the consumers and the public interest as a whole are being looked at. We also need to be mindful that when there are events such as major storms that challenge or call into question the utility performance and or the regulator's oversight of that performance, that the issue of the appropriateness of incentives and disincentives will come up. So it is really important for us to look at what we are doing from a fiscal prudency perspective, what we're doing from an accountability perspective, and whether our stated goals are being enabled in a way that is helpful. So the questioner is really right to focus on what is the right balance, what makes sense, and this balancing act is one that is ever present in all of our utility regulation, not just cloud computing. And frankly, I see it as at the core. We need healthy utilities, financial healthy utilities. We need a reliable and affordable energy systems. And the goal very much must be keeping consumers and the public interest at the center of it all. Before we move to the next question, does any of the other panelists want to add anything to this? Okay, great. Hearing none. The next question I'll ask is, and I'll put this to Amazon Web Services, and if others want to chime in after. Personal information security is a top concern for regulators and consumers alike. We've saw a number of different questions as relating to for the protection of that. How does AWS protect consumer personal and private information?
Yeah, thanks, Commissioner. So needless to say, we're very vigilant about our customers' privacy. And we have implemented a number of fairly sophisticated technical and physical measures to prevent unauthorized access. We have a dedicated, for instance, we have a dedicated team of security experts that monitor our systems 24/7 and dedicated to protecting customer content specifically. We have we have a number of, I mentioned also during my presentation, that customers can choose, and many do, to encrypt their content as part of the standard security process for highly sensitive content. We provide tools that to that end, and customers can encrypt their data at rest and in motion, and or they can procure applications through our marketplace that that are specific to security and meet their security needs. And needless to say, content that has been encrypted is rendered useless without the decryption keys which the customers keep. So the data, we have our own physical and technical solutions, and on top of that, customers can choose, and as many do, to really encrypt the data and make it unusable and inaccessible to anyone who does not hold the key, the decryption key, which is held by the customer.
Great, thank you. Does anyone else on the panel have anything to add to that, or in general, what you perceive as important regulatory actions that would complement the security of personal information? Rick?
Well, I think in general, security is always going to be an issue when you're talking about cloud computing, and education is pretty critical to the boundaries, as our friends from Amazon talked about earlier, on what's the utility's role and what's the technology provider's role. Another issue with security, I think in general for utilities, is a lot of our systems that are aging are very difficult to maintain the latest patch. If you look in the Wall Street Journal, any of these big papers with these major hacks, it's typically an older piece of technology that wasn't maintained. I think that's another advantage for considering cloud types of computing, because that's the technology provider's role and responsible to maintain those patches of being current. And I have another general comment about the economic issue you brought up earlier. With the software as a service model, those models that are utility specific applications are emerging rather quickly now, but we don't have a lot of track records for big enterprise, like customer information systems in the cloud yet. We will soon, because there are many people implementing those now. A few have gone live already. But with those models, the market's going to create additional value. I think it's a little bit more difficult to capture when you come to the bottom line of the financials. For example, these SaaS offerings are also including upgrades many times. A lot of the challenge I think we have with all these older systems, which create problems, as we discussed a moment ago, is they're not maintained. This model, many of them are including automatic upgrades to the new version. So that will be, I think, a pretty critical factor in calculating the total cost of ownership of a legacy or a new, let's say, on-premise system to a new cloud SaaS hosted system. And I think when we look at our costs for rate cases, we have to be thinking about what's the cost to implement a new modern system versus my old fully depreciated legacy system cost on an operational perspective versus a new SaaS model, if that makes any sense.
Thank you. I think I also would just pause to add sort of two things here, is that a lot of these issues that we're talking about it's not necessarily specific to cloud computing, but it is something that can be helpful by looking at other areas. When we look at data access, when we look at security, grid modernization, what's the appropriate cost, that we look at it from a cost recovery perspective, and that some of these challenges and barriers are something that we should look to how we have traditionally handled it, and how when we are moving into other out-of-box solutions, what makes sense. Keeping paramount that our overall goal is the security and reliability of the system, prudent investments, as well as ensuring that there is a customer benefit to all of this that is really tangible. And as we move towards AMI and some other things, these are things that can help us from a visibility perspective look at that. We are reaching the witching hour, and I do want to ask a final question to the panelists, which is, what do you see, each of you, as the most important key takeaway or takeaways for regulators and or industry to keep in mind as we move forward in this space?
I think we need to look at the issue that Danny brought up earlier, right? And the question about shouldn't utilities be purchasing the lowest cost technology or item regardless? I think we need to consider they're also running a business, and we need to make sure that the economic model is advantageous to all parties involved.
Yeah, I think it always benefits customers to the extent we can align the utility business motivations to the benefit of customers. And so to the extent there's a disconnect in regulation, resolving that, understanding that our ideals don't always meet up with practice, and that incentives work. I mean, if there's an incentive, it may not always govern the outcome, but it usually has an influence. So that's what I'd like to leave you with.
Great, thank you. Joe, do you have any thoughts on this?
Yeah, thank you, Commissioner. I guess very simply, right? We heard today how cloud services can help consumers and benefit utilities alike. They're secure, they're resilient, they're scalable in ways not available or economical on premise. So I would urge to support and foster, the utility interest in cloud services so they can adopt them without having to compromise.
Great, thank you. I think sort of my perspective is also looking at this as we can see with the 5 state actions that are on this page here, is that we also need to continually engage with our regulated entities and the various stakeholders. And again, look at what this means overall for the public interest and how we can unlock some of these technology challenges, still remembering our core basic regulatory values from an economic perspective, an environmental perspective, and a fiscal perspective are really, really key. Does anyone have any final comments or thoughts before we wrap up? Nope.
Not on my end. Thank you, Commissioner.
Great, thank you so much. Let's give a round of applause to our panelists. Thank you very much. Virtual shout out to all of you. You did a great job and I really appreciate it. It's a critical issue. NARUC is going to be continuing to engage on this issue, and states that are interested in following this, they're also keep in mind FERC and NERC are both looking at cloud computing and technology capabilities in general, especially as it relates to cybersecurity and the bulk power system. And it's something for us to be mindful of and keep in mind. Thank you all. Bye-bye.
Thank you, Commissioner Berman.
Thank you.
Thank you for the opportunity. Thanks, Commissioner Berman.
Thank you.
Thank you as well. Goodbye.